This is lactometer. A lactometer is an instrument to measure the specific gravity of milk, that is density of milk or purity of milk, to check for adulteration such as addition of water. A lactometer works on the principle of density, specific gravity of milk. Pure milk has characteristic specific gravity, which decreases when water is added. The lactometer floats higher or sinks lower based on the density of the milk. If the lactometer sinks more than usual, it indicates the presence of water. If it floats more, it indicates the presence of starch. So now let's start with the experiment. So first of all, I'm taking milk in test tube 1. We're checking the purity. So your milk is taken in test tube number 1. In this, I will dip a lactometer. Take care that the lactometer should not touch the wall of the test tube. So here I've dipped the lactometer. Now let's check the readings. The reading is around 10. It has sinked more in the milk. Means here the water is added in the milk. The milk is highly diluted. You can see the readings. It's around 10. So this milk is adulterated. Here water is added. Okay, you have seen. Here you can see now it is 10. Again, one thing, the temperature should be around 20 degree. So here the room temperature is 20 degrees Celsius. If the temperature is less or more, then it has to be calibrated. That I'll tell you later on. Now this is test tube number 2. I've dipped lactometer in this. And let's see the reading. The lactometer is floating. And the reading is around 31. And this is a pure milk. The typical range of pure milk is in between 26 to 32. Calibration of lactometer with reference to temperature is essential because the instrument is designed to give correct readings only at the specific standard temperature. Lactometers are usually calibrated at reference temperature, either 20 degrees Celsius or sometimes 27 degrees Celsius as per Indian standards. We are referring Balbharti book, Maharashtra textbook. So we'll be considering 20 degrees Celsius. So let's start with the calculations. As per Balbharti, the temperature of milk should be 20 degrees Celsius. For every 1 degree Celsius below the calibration temperature, subtract 0.2 from the actual lactometer reading. So here example 1, the milk temperature is 17 degrees Celsius. So 20 minus 17, it is equal to 3. So 3 into 0.2. So here we have to minus 0.6 from the actual lactometer reading. Lactometer reading here is 30.6. So final reading will be 30.6 minus 0.6. That is 30. The final reading will be 30. Now in example 2, the temperature of the milk is 23 degree. Now for every 1 degree Celsius above the calibration temperature, we have to add 0.2 to the actual lactometer reading. So here the temperature of the milk is 23 degree. So the difference of 3 degree. So 3 into 0.2, that is 0.6. Lactometer reading is 30.6. So here we are adding to 30.6 plus 0.6. That becomes 31.2. So the actual final reading will be 31.2. Now, let's find the specific gravity for sample number 1. Example number 1. Specific gravity of milk is corrected lactometer reading upon density of water, that is 1000 plus 1. So here 30 upon 1000 plus 1, it becomes 1.030. And for example 2 will be 31.2, that is density of milk upon density of water, that is 1000 plus 1, it becomes 1.031. So for example 1, specific gravity is 1.030. For example number 2, the specific gravity is 1.031. So here the milk is pure because the specific gravity of milk, pure milk, is in between 1.026 to 1.032. Let's see the other example. Sample 1, example number 1, milk temperature is 27 degree. The normal room temperature is also 27 degree and milk temperature is also 27 degrees Celsius. And the lactometer reading is 30.6. That's difference of 7 degrees Celsius. So to add 7 into 0.2, it becomes 1.4. The final reading will be 30.6 plus 1.4, that is 32. Specific gravity corrected lactometer reading, that is 32 upon density of water, that is 1000 plus 1 is equal to 1.032. So for sample 1, the specific gravity is 1.032. It's in the normal range, that is 1.026 to 1.032. So sample 1 is a pure milk. Now let's see sample number 2, example number 2. Milk temperature is 27 degree. The lactometer reading is 10.1. Coming to the correction, 7 into 0.2, with the difference of 7 degrees Celsius. So 7 into 0.2 is equal to 1.4. Final reading will be 10.1 plus 1.4, that is 11.5. Coming to specific gravity of milk, that is corrected lactometer reading 11.5 upon density of water, that is 1000 plus 1 is equal to 1.011. Now this milk is diluted. You can see the range. It is 1.011 and the normal range is 1.026 to 1.032. So this milk is diluted. It is adulterated, diluted with water. So this was all about the specific gravity.